This is only a demo version of the project I wish to make. This has everything I want except for Bluetooth to control everything. I'm gonna have the LEDs and flag be more for attention grabbing, and the LCD screen I'm gonna do my best to allow it to print text and symbols, which you input to your phone and then send to the board. A good use for this would be for people who can't speak. They'll be able to grab everyone's attention, and they'll be able to display what they want to say on their screen without needing pen or paper. All they need is just this setup.
Here we have the breadboard view of my circuit. We have the Arduino 101 board right here and the breadboard down below. All these purple wires are the PWMs that I use to control the board, and the cyan wires are the normal digital outputs from the board using the pins. Down here we have a red wire to connect to the breadboard for the 3.3 voltage, a blue wire for the 5 volts, and black for the ground. Over here at the LCD screen we have the ground connections, the normal voltage connections, and all the pin connections, and we have this yellow wire leading to this potentiometer hooked up to the 3.3 volts and ground. We are using the variable from the potentiometer to change the brightness of the screen. Over here is the servo getting voltage from 5 volts pin, grounding, and we're also getting the PWM reading from pin 6. Over here is the shift register where we have 2 voltages going in, 2 grounds. We are using a PWM and 2 digital pins. This is shift register, and we're using 5 of the shift register's outputs. Down here we have it grounding to a 100 ohm resistor going all the way back to the breadboard. Right now we have the schematic view of our circuit. We have the Arduino 101 board up here. We have a red wire displaying the 3.3 volts going to the LCD screen and the shift register. And we have a ground, this black wire connecting to all of them. We have the same color wires for the PWMs and the normal digital pins from the Arduino board. This is the potentiometer which connects to the LCD screen. Over here on the shift register, we have all 5 LEDs connected to the ground through the resistor. And on this LCD screen, we have the same wiring, all the grounds, same pins. And over here we have the servo, which is getting voltage from the 5 volts and gets grounded through everything else. This is the Arduino code for my circuit. We have the comments explaining everything about my circuit, why I built it, what it's from. This line of code gets us the library for the LCD screen, and this line here sets the pins that we use for the LCD screen. Then we include the servo library, and we name that servo servo1. Now we create some variables which we use. We create a long for time. We create 3 ints for the pins we are using for the shift register. We also have another variable for data, which is also used by the shift register. Down here in the setup, we start with initializing the serial print screen. We then set the servo to pin 6. We set all the pins for the shift register to outputs. We set the dimensions of our LCD screen, and we clear that screen in case there was anything left on it from before. And then down here is another loop, which is referred to in the program. it's void shift right. We use all these and we create bit right using data, desired pin, and desired state. We use shift out with data pin, clock pin, MSB first, and data. And then we turn latch pin on and off. Latch pin activates when in the transition from on to off, so that's why that's set up like that. This is another loop that the program refers to. It is called LED control. We have integer for index and integer for delay time. Index we set to random 5 because we are using 5 of the shift register's pins to use, and we're using shift right index plus 2, just the pins that I used from the shift register. There are for the 2 through 7, and we then delay, and then we turn it back off, and it repeats. With that out of the way, we go to the main part of the program using a normal void loop. First thing we're doing is we're setting time to the milliseconds since the board's been running the program divided by 1,000 to get actual seconds. This next if, else ifs, and else are to set a variable that we need time to be. If time divided by 3 for my 3 seconds I want each screen to be on is greater than or equal to 50, we are going to take time set to time divided by 3 for that 3 seconds still, and we're going to subtract 50 from it to allow a repeat. This happens for 40, 30, 20, 10, and it's just divisible by 3, and it's not greater by any of these. It'll just divide it by 3. This is my solution to allow it to repeat. If I want it to repeat more than the amount of times I have right now, I just keep adding more of these. It's my simple fix. I then serial print time so I can know what mode I am in. We are now into the part of the code that actually runs all things and shows everything that we see. It is a switch case based on time. Since time is divided by 3, each case is 3 seconds long. For when case is 0, we start with the clear, and we print the first line, hello, my name. And then we set the cursor down to the second line, and then we set it to print is Kevin Nolan. So on the LCD screen you see, hello, my name is Kevin Nolan. Now we use LED control, which was that loop prior I showed you, where it uses the shift register to set the pins of what we're using. And then we're setting the servo to go to position 30, which I found by just testing with the servo to find where its limits for my hat will work. And now we break out of case 0. Now we're in case 1. We do the same thing. We'll do the clear, set the cursor to 0, 0, and print my text. Same thing, we go to LED control to allow it to keep changing the LEDs that are on, and we set the servo to the opposite side that I found by testing, which I determined was 170. Then we break again. This repeats on for many times. I will still show each line of code though. We do a clear, we set the cursor to 0, 0, print the first line, set the cursor to the next line, print the next line. We then have it so it can run the LEDs changing, and we set the servo to go back again. We then break out of the case, and we're on to case 3. In case 3, we're doing a clear, set the cursor to the first line, and we're printing the line I wanted of text. We're controlling the LEDs, and we're setting the servo. We're breaking out. Case 4, we're clearing, setting the cursor to 0, 0, printing the first line, setting the cursor to the second line, and printing our second line. We're then controlling the LED, moving the servo, and then we're breaking out of case 4. Case 5, we're doing a clear, setting the cursor to the first line, and we're printing "Save Me Please," whatever text I chose still. We are controlling the LEDs again, changing the servo position, breaking it out of case 5, entering case 6, clear, set line, set print text, control LEDs, set servo, break. So we're running repeat now. Case 7, clear, set the cursor, print the line, set the cursor, print the line, control the LEDs, move the servo, break out of case 7. Almost over. In case 8, clearing, setting the cursor, printing the line, setting the cursor, printing the line, controlling the LED, setting the servo, breaking out of case 8. It's almost over. Case 9, we're clearing the screen, setting the cursor, printing the text, setting the cursor, printing the text, controlling the LED, setting the servo, then we break. Now we're in default. This is what happens when once time breaks its barrier, or we saw above, which was when it gets to 59, when it turns to 60, it will be too high for it to now count, divide by 3, and work. So it'll go into this loop where it just clears the screen and everything stops running. So just ends there. Break out of that, and that's the end of the program. I am now going to show you the display. As you can see here, it is displaying a number. This number is the time after it goes through all of its equations. It goes from 0 to 9 and keeps going through 0 to 9 for a few times. And after a while, it should count after 9 because my equations will stop once it gets to a point where it's 59, where it subtracts 50. I only go up to subtracting 50, so it'll count to 10, 11, 12 after that. So this is just to, you can see which mode in the case which you're in. So like this is 1, this is 2, the next one was 3, there was 0, which is case 0. Just goes 0 to 9. That's pretty much it.